I'm Dave Clements, Senior Lecturer in the Physics Department at Imperial. I work in the Astrophysics Group on extragalactic astronomy and observational cosmology. Cosmic microwave background is the oldest light in the universe. It's our view of the Big Bang, about a couple of 100,000 years after the Big Bang, when the universe became transparent for the first time. So we're looking at photons that were the glow of the microwave background of the universe at that time, which have been free streaming towards us ever since the universe became transparent in what's known as the recombination epoch, when protons and electrons combined together to form hydrogen atoms for the very first time, and that's when the universe became transparent. Well, the way we usually look at the CMB, the map of the entire sky in the microwave background, is as a flat map on a piece of paper. And to do that, you have to take the sky, which is obviously spherical, and squish it much the same way as you would do when you peel an orange, and then squish it down onto a piece of paper and try and make it flat, and it won't turn out to be a reasonable shape. So that means you're going to be distorting things. So if you look at how that works with a map of the world, Greenland always looks enormous, and conversely things around the equator are usually squished. So there's a number of different ways of doing this, various different projections. You've got Mercator, Peters, etc. But frankly, the right way of doing it is to look at it as a real sphere. Now you can do that with computer graphics. You can produce what looks like a sphere on a screen and use a mouse to move that around. But that's all still reliant on vision. And we have other senses. Some people, actually, who are visually handicapped, don't have the ability to look at things quite that way. So why not produce something that you can hold, an actual real object where you can feel the lumps and bumps, bring an extra sense in, touch as well as sight. So you can feel the lumps and bumps where the microwave background is a little bit hotter or a little bit colder. And that's why we produced a sphere. This is our model of the microwave background. And what we're looking at here, magnified by quite a large amount, is differences in temperature. So the big bumps, that's where the microwave background is a little bit hotter than average, and the blue bits where the microwave background is a little bit cooler. Now these are the temperature differences about 1 part in 100,000. So if the lumps and bumps were to scale, so 1 part in 100,000 higher where it's a little bit hotter, similarly where it's cooler, a dip, this would be smoother than a billiard ball. So we had to magnify those. We also added color, so it makes it easy to see what's going on. But that's what we're showing, is where things are slightly warmer, where things are slightly cooler. And these are important because, as well as being regions of increased temperature here, where this red bit here, where it's slightly warmer, those are also parts of the universe which are somewhat denser. And these small regions where there's a slight enhancement of density, those are the seeds for the formation of structures. They grew through gravitational attraction of material over the many millions of years between the Big Bang and now. And these regions that were slightly denser, that's where the first stars formed, where galaxies formed, and it produces everything that we see today, from the sun, the planets, to us. It's all because some of these regions are a little bit warmer, a little bit denser. Anybody can make their own 3D microwave background. They can download the files that allow you to make this with a 3D printer, and then, admittedly, you then need a 3D printer. But there's a wide variety of them, some not quite as smart as this, producing colors and everything. I wouldn't put it past somebody trying to whittle one out of wood. That's also possible, but that's going to be rather more of a craftsman job than what I can manage. But yes, the files are out there. If you have a 3D printer or know somewhere where you can use one, there are hack spaces dotted around the country after all. Go out there and print one for yourself.